Hello, Dr. Dadlez here. Welcome to 6th grade STEAM camp. Today we're going to be taking a look at how science can actually blend math and art. As we take a look at these beautiful plants and flowers, we're going to delve deeper into the patterns that they offer. Welcome and join me as we look closely into science and art. Hello, and welcome to 6th grade STEAM camp. My name's Dr. Dadlez, and I'll be taking through our activities today. Today, we're going to be focusing on art. So first, we'll kind of go through a few different activities to kind of introduce you to some of the things that you might find that correlate with science and art, and then we'll be getting into some activities. And in these activities, you'll see how art and math and science are all interrelated, especially when it comes to my favorite, nature. Absolutely. So I love going on nature walks, taking a look at how the leaves and the flowers all form these beautiful patterns that are found in nature. And oh, well, hello there, Alexander. Nice of you to drop in. Um, very, very good to see you after your engineering experiments, right? Hmm. You don't seem to be taking it too over easy. Why don't you just come hop in my pocket over here and we'll go on a nice, relaxing nature hike? Great. There are going to be three parts to our day today. So, first, we're going to take a look at the patterns that often occur in nature. And next, we'll head outside to see what kind of patterns we can find. And finally, we're going to use some of these patterns that are found in math and art and create our own Fibonacci fractal pattern based on nature. Okay, sounds great. Let's get started. So, the first natural pattern that we often see are lines and waves. All right, so you can see in these incredible sequoias that there are just these amazing straight lines that are found throughout the entire forest that artists have to reproduce then on their canvases. But if we go out to Great Sands National Park, you'll see these amazing dunes made out of gypsum. But look closer. And as you look closer, you'll see these incredible wavy lines that cover every inch of these dunes. It's really amazing to see. We can also see circles in nature quite a bit. So they're found in things like these tree rings, and these are called concentric circles. This means that they all have that same center, but the circles keep radiating out, getting larger and larger, all inside of each other. Kind of like this amazing tree ring that you can see that starts off with that center circle where the tree first started growing, and then over hundreds of years have created this incredible ring. Nature also has stripes and spots. So if we look here, take a look at these stripes. No, look closer, really closer. Don't see it? Ah. So those lines and those stripes help create an amazing camouflage. Whoa, amazing. But there's also spots. So when I was out looking at flowers, all these white spots, these are all incredible flowers. But again, look closer. And as you look closer, you'll see in this California 5 spot, there are exactly 5 purple spots. Bonus, you got all these lines on there too. Pretty cool, huh? We can also find branching and meandering going on in nature. So this leaf has incredible branches coming out of the veins that almost mimic the tree that it came from. In the same way, we've got this incredible meandering path that looks like a snake as this river just meanders through this floodplain. When seen from space, you can see it meandering, but also branching off into these smaller branches that almost look like the tree that we saw earlier. We also have examples of symmetry in nature. So this is where you have like this half of something matches the other half of something. So if I were to fold that leaf in half, they match up perfectly. Just like the wings on this butterfly match up along that line of symmetry that's its body. We also have spirals found in nature. These beautiful leaves that are unfurling as they grow in the spring, or the snail shell that you're taking a look at oftentimes in your own front yard. Spirals can be very small. These are 1.5 millimeters. Think about the tip of a pencil. Or they can be very large, like this entire incredible galaxy. There are also explosions and fractals in nature. This fan looks like it's exploding out from the bottom with this explosion pattern radiating out on its wonderful California palm leaf. But we also have this pattern of a fractal where things are getting smaller and smaller and smaller, but also radiating out from the center. So, how many examples can you find? You are going to take your nature journal and you're going to go out into your schoolyard. You're going to look closely for some of these patterns. And so you'll fill this out as you go. What do you notice? What did you wonder? What does this pattern remind you of? Have you seen any of these patterns elsewhere? I also left you a spot to make a little bit of a doodle. When you come back in, you're going to be discussing some of these patterns that you found that are similar or different from some of your friends. So remember to go out to the spot that your teacher tells you that you can look for any of these nature patterns. And remember, look closely. Listen for your teacher's signal to return and then share what you found with each other. I'll see you back here in about 10 minutes. Hello, welcome back from your nature hike. We're going to take a look at another part of our lesson today, and we're going to be talking about Fibonacci patterns and fractals. So, I've got a bit of a question for you. I'm going to show you a series of numbers, and I want you to see if you can't figure out the pattern. So, let's take a look. So, if we're looking here, we have a 1 and a 1, 2, and then a 3, 5, and 8, a 13. How did this 1 and this 1 turn into 2? And this 2 then change to a 3, change to a 5, change to an 8, change to a 13. So this pattern was discovered by Fibonacci. All right. Who is Fibonacci? Glad you asked. So he's this great European mathematician, and he was born in Italy. And he introduced the Arabic number system, which includes 0 or base 10s, 10s, 20s, things like that. He introduced that to Europe. He also started the decimal system. And he was the one that came up with this interesting sequence of numbers. He was thinking about rabbit populations, and he came up with this pattern that he kept seeing over and over again. Fibonacci discovered this amazing number pattern. He noticed that if you had 1 and 1 and added them together, that they made 2. But then if you took the 2 and you added the previous number, 2 plus 1, you got an answer of 3. If you took 3 and you added the previous number, 3 plus 2, you got 5, and so on. So this sequencing can actually be found in flower petals. I want to take you a little bit of a tour of that. Let's take a look here. So here, sometimes we have one flower petal. This one just goes around in a bit of a spiral, right? But then let's add 1 to 1, and we end up with 2. And so here we only have 2 flower petals on this very unique looking flower. And if we add 2 plus 1, we end up with 3, like this trillium that can be found in the woods with the 3 petals. 3 plus 2 is 5. You won't very often find a flower that only has 4 flower petals. The most common in nature are these 5 flower petals as found on this pansy. 5 plus 3 is 8. And so many flowers that you'll find like this cosmos will have 8 flower petals. And 8 plus 5, well, that makes 13, like found on these gold fields in our California wildflowers. And 13 plus 8, you're going to end up with 21. Oh my goodness, like this zinnia over here, and so on and so forth. So when you're looking at these flower petals, look closer. Spend a little bit of time really thinking and noting exactly how many number patterns might be on there. It's pretty amazing. The Fibonacci sequence can also be found in shapes. Let's take a look. Isn't that just an amazing looking natural shape? This spiral can be found in many places in nature where things start off with that one in the center and then they build with another one, and a two, a three, and it just keeps going larger and larger and larger, just like you find here with the spiral on this nautilus shell. Okay? But it can also be seen in many other places, okay? Such as the seeds as they are in a sunflower, okay? And they can also be found in these roses too. So these spirals are amazing, but then we can add another layer onto there, and those would be fractals. Now, fractals are an amazing mathematical shape where if you take this shape, it repeats itself again and again, getting smaller and smaller and smaller. So think about that spiral, but in reverse. So this entire frond, if we were to look closer, it's the same shape as one of these small fronds, but it's also the same shape as one of these teeny tiny fronds. And so as you zoom in or zoom out, you get this same shape over and over again. It's just a repeating pattern that's found in nature, such as in these leaves, or patterns that can be found in these flowers, with this hexagon that repeats over and over again, or this star that repeats from the center of the flower and then works its way on out. Now, what's really awesome is if you have a Fibonacci spiral, and you also have a fractal appearing at the same time, like in this amazing succulent plant. And that's what we're going to be looking at today. So let's create a Fibonacci spiral fractal. So look at this example here. What shapes do you see? So most of you would say that you saw squares and that you saw triangles. Well, what if I told you that there aren't really any triangles in there? What's the largest shape that you can see? Look closer. Is that large shape, that largest square right there, that's how this whole pattern started. And then it just began to spiral. If you take that large square, you can look at it, divide it into fourths. This whole thing is made with just the square. Okay? And this repeated pattern, when it gets layered on top of each other when you draw it, that's what's make the triangles. And so this is going to look a lot like our succulent pattern that is a fractal and a Fibonacci spiral at the same time. Can you see that? So we're going to create a Fibonacci spiral fractal. Now ours is going to start off with a couple pieces of origami paper and scissors, and you're just going to work your way on through the pattern with me, and I'm going to show you up close. We'll start off with that one piece of origami paper, and then I'm going to show you how to tilt it a little bit, cut it down and rotate it. We'll trace it again, and then we're going to tilt it, cut it down again, and trace it again. And we're just going to keep on cutting and tracing until we have an amazing Fibonacci spiral fractal. Hi, Dr. Dadless here again. Let's take a look at the project that we're going to create to make that Fibonacci fractal. So, first thing you're going to want to get is you should have a 11 by 17 piece of paper. So you're going to want to open that. You want to tape it down with a little bit of the Scotch tape there. Just tape it in the corners. And you're going to need a single Post-it note. All right, if you make a mistake, you might want a couple more just to keep on the side in case you make a mistake. All right. We're also going to need a ruler, a pencil, scissors, and in a little while at the end of the project, you'll need your colored pencils to color in your fractal when you're done. All right, ready? Let's take a look up close. So the first thing I'm going to do is I'm going to take some of my masking tape and I'm going to tape the corners of my paper, because as I draw on it and rotate it, I want to make sure my lines stay nice and straight. So we're going to make sure that's nice and smooth. Get that taped on there so nothing is moving. Okay. All right. So then the next thing I'm going to do is take my Post-it note, and I'm going to start not quite in the center of my paper, but a little bit down. All right. And I'm going to stick my Post-it note on there, right there. And I am going to draw a dot in the corner so that I know that this is going to end up being the start of my whole spiral, my whole Fibonacci spiral that I'm going to make. Okay. So get your Post-it note on there and draw your dot. When you're all set, give me a thumbs up. The next thing I'm going to want to do is to trace my square. So I'm going to take my ruler and I'm just going to line it up, get things traced. I am tracing really dark so that you can see it, but you are going to want to make your tracings kind of light because you don't know what color you're going to be making them later. So I'm going to trace all 4 edges of my square. And then when I'm done, you can see I have all 4 edges of my square on there. Okay. So the next thing we need to do is to take a look at the left side of your square, and we are going to find, I'm going to use that again. We're going to find the exact middle of your square. I think it's right about here. Just to make sure, I'm going to put my pencil in the middle. That's about 1.5 inches on one side and 1.5 inches on the other. If I wasn't sure, I could measure the whole thing as 3 inches. So that means that 1.5 inches is exactly the middle. And I'm going to draw a line to show that it's exactly in the middle. All right? So you want to measure, find the middle, and draw a line. You can double check by looking, 1.5 inches on that side and 1.5 inches on that side. So find the middle. When you're set, give me a thumbs up. put my Post-it note back in my square. I'm going to make sure it's exactly fitting just like it did. Okay. And now I'm going to fold it diagonally. So I'm going to fold it along this diagonal right here. Just going to fold it in half diagonally. Make sure that corner matches. And I crease it. Yep, got a little sticky on my finger, but that's okay. All right, so now I have my diagonal. I'll wait for you to do that. You're just going to take it and you're going to fold it and crease it diagonally. Tell me when you're set. So now I am going to rotate it. This is my spot that I made, and so this is always going to be my center. I'm going to put my pencil here so I can just rotate it, okay? But I'm not spinning it any particular place I want to. I'm going to spin it directly to that half mark that I made. That crease is going to touch the mark. Rotate it until the crease touches the mark right there. Let me show you that again. Start it off here, and I'm going to rotate it right to that mark. Once I have it in place, I'm going to put an X on there. Great. Now I'm going to lift up my Post-it note and I'm going to make it so that the X is facing me, and that's going to become where I'm going to fold this in half and make it smaller and cut it. So I'm just going to fold it in half right on that X, making sure that's nice and straight. And I crease it. Let me show you again. I've got my X. I fold it. I make sure that it's nice and straight here, and I crease it. There's my X. I fold it and crease it. Okay? Once I have that line, that gives me a nice straight line to cut on. This piece I don't need. I now have a smaller triangle. Let me know when you've got that part. I'm going to open my triangle. Now I have a square again. I'm going to take my square and I'm going to put it right on that dot that I put there. And I want to make sure that my tip touches that line that I made before. I'm going to rotate it a little bit. Oops. And now my tip is pointing directly to the line I made. Once I have that in place, I can trace all those outer edges again. Okay, so I put it on the dot. I match my corner up with my little half mark, And then I traced all around it to make a brand new square. In this square, I have to find on this line, where is the halfway mark? I think it's right about here. Let me measure and check. That's 1 2/8. That's 1 3/8. So I actually got to be over just a tiny bit more. Okay, and I'm going to mark. That's my middle. Again, I'm marking dark so you can see. I'm going to put my square back in its place. I'm going to fold it so it's a diagonal. Hold in its spot again. I'm going to rotate until the crease touches my halfway mark, and I'm going to mark it right on that line. When I've done that, I need to pick it up so that I know that this is the part that I'm going to cut off. I'm going to fold it right on that X. Make sure that it's nice and lined up appropriately. Got a nice crease going there, and I can cut it down to size. I don't need that part. Now I have a new square. Come back. I'm going to put it right on my dot. I'm going to rotate it until the tip, the corner of my square, it's okay if it's off a little bit, is touching the halfway point again. And I'm going to trace my square. You guys can use your ruler. I just want to be able to show you how this starts working out. I have another square. On this square again, I have to find the halfway point. It starts getting a little weird when I see all these other lines. So measure here, it's 2 1/4. So it's got to be 1 1/8 right there in the middle. I mark my middle point. I bring my square back. I fold it into a new diagonal again. I can see the line of the old diagonal, but I need to make sure that this diagonal fits this sized square. Put that tip right on that dot again. Scooch it over so that I can see where my crease touches. Make an X. That tells me to cut this part off. I'm going to fold it. Nice and creased. Now I've got that line to cut on. It's definitely a shrinking square. Okay, so here's my new square. Comes back. I touch it one corner to the dot. That opposite corner rotates to touch that halfway mark that I drew. I hold it in place while I trace it. Now I have a new square that's smaller. I need to find that halfway point that's on this line right here again, that outside line every single time we keep coming back to. Let's see. This one is 1 3/4. So middle is not quite an inch. That's in the middle right there. I mark it. I bring my square back into its place. I fold it so it's a diagonal again. I'm going to put my pencil on its corner so I can rotate it. I rotate it so that it's touching that halfway point again. I mark it so that I know that this is the spot I need to cut off. I'm going to fold it, crease it, cut it. Open it back up again. There's my new square. It goes back to its spot. I hold the corner in place in the center dot, and I rotate so this corner is touching and pointing to that halfway mark that we made. Sometimes you got to double check that your square is actually a square, because sometimes it starts looking a bit more like a slated rhombus or a trapezoid almost. So you got to be making sure that it's actually a square. Okay, so here's my new square. I'm going to find that halfway point on that outer line. That's 1.5 inches. So that means I'm going to be at 3/4 of an inch. Right there is the middle, 3/4 of an inch. I return my square to its spot. I fold it along its diagonal. My pencil tip holds it in place in the center. I rotate it so that it's touching exactly where that halfway mark is. I draw a line and an X. That way I know I'm going to be cutting off this part here. I'm going to fold it, crease it, and cut it. Here's my new square. Back into its spot, hold it at the center, rotate it so that the tip is touching the halfway point, trace it, and we're just going to keep going and going and going. Your square is going to get smaller and smaller and smaller and smaller and smaller and smaller and smaller. You will end up with a square that is approximately that big. All right, so I'm going to let you work on that. Just keep finding that middle, doing that diagonal, and cutting it down a little bit. When you're ready, you can erase a little bit of those little halfway marks that you had made. Once you continue your whole spiral. So keep working on that, and then we'll get to the next part in just about 5-10 minutes. Welcome back. Now that you have had an opportunity to trace each and every one of your Post-it note squares getting smaller and smaller, you should have a really cool spiral fractal. So now you're in a color creation your way. Right now, you just have it all traced out in black and white, and you can choose whatever you would like to be able to color a pattern. So you can just go ahead and color it in whatever geometric shapes you find, or you can emphasize the fact that there's a spiral going on there and call that out. It's up to you for how you would like to create your colors. Don't forget that botany, the study of plants, and these observations of those patterns in nature have helped artists for many years create amazing things, like this red poppy painting by Georgia O'Keeffe. You can see that wavy line pattern here. You can see that explosion pattern and the symmetry that she used to be able to paint this red poppy. You can also see how Vincent van Gogh painted these sunflowers with careful attention to how many petals he used on each and every sunflower following that Fibonacci pattern. Speaking of a Fibonacci pattern, this incredible great wave shows that Fibonacci spiral, as does Vincent van Gogh's Starry Night. Look closely and you'll find the beauty of art in science. Thank you for joining us today at 6th grade STEAM Camp, and we hope you continue to look closely and find beautiful things.